Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper trending on X, published on July 16th, 2025, just 3 days ago. This paper proposes a new framework that speeds up LLM inference by up to 5.2 times without losing any generation quality. The paper is titled, "Your LLM Knows the Future, Uncovering Its Multi-Token Prediction Potential," and the results for specific tasks like coding are really impressive. The authors show that standard LLMs already contain rich information about future tokens, even without being explicitly trained for it. So, the authors start by showing how this latent knowledge exists even in standard models. This first figure really illustrates their core idea. On the left, we see a model using what's called next token prediction, where it just guesses the very next word. For the prompt, "What is 2 plus 2?" the correct future words are there, but they're scattered. In the middle, using their multi-token prediction method with special mask tokens, the model's output gets more structured, pushing the correct words into the top 10. Finally, adding a sampler module further refines everything, creating a coherent, correct sequence. Moving to the results, this next chart really quantifies the speedup across different tasks. The full method, shown in yellow, achieves a speedup of over 5 times for both math and coding. This is because these tasks are often more predictable. The authors achieve this using a technique called gated low-rank adaptation. Low-rank adaptation is a method for efficiently fine-tuning a model by only adding a small number of new parameters. And the gated part here acts like a special switch, preserving the model's original quality while adding this new skill. And this diagram really breaks down how the whole system works. The model takes the input text and adds special mask tokens, which are just placeholders for the multiple words it will predict at once. This all goes through the main model, and then a special sampler module at the bottom assembles these predictions into a coherent sentence. The key part is on the right, the gated low-rank adaptation module. It smartly directs traffic, using the original model for standard predictions, but activating a new, efficient path for this multi-token prediction. Alright, and these next charts really drive home why that gated low-rank adaptation module is so critical. On the left, you see accuracy on the ARC challenge benchmark. The gated low-rank adaptation method in blue maintains its high accuracy, but the standard method's performance degrades significantly. Then, the chart on the right shows the next token prediction cross-entropy, which is just a measure of error for the original task. Again, the gated method's error stays low, proving it preserves the model's quality, while the standard method actually gets worse at its original job. So, with quality preserved, this table then breaks down the speed-up performance across different skills. The columns show what happens as you add more mask tokens, from 1 all the way to 8. The numbers themselves are the speed-up factor, which is tied to the acceptance rate, basically how many of the model's predicted future words are correct and get used. You can see for math and coding, on benchmarks like GSM 8K and Human Eval, the speedup is huge, over 5 times faster. This is because these tasks are just more predictable. Building on that, this chart shows an ablation study, which is just a way of seeing how much each individual component contributes to the overall speedup. The bottom light blue layer is a basic method. Then, adding quadratic decoding, a smarter way to verify tokens, gives a boost. On top of that, the sampler module adds even more. And finally, the top layer comes from using a latent consistency matching loss, which is a special training objective that ensures the multi-token predictions stay consistent with the original model's single token outputs. Each piece clearly improves performance. So to wrap things up, this research really shows that standard LLMs have a hidden talent for predicting multiple words at once. The key takeaway is that by using a clever combination of techniques, like the gated low-rank adaptation to protect the original model and a special consistency loss to ensure quality, we can unlock this potential. This leads to massive speedups, over 5 times for tasks like coding and math, without any drop in performance. It's a powerful way to make these models much more efficient. That's all for this week's AI Research Roundup. Thanks for tuning in.